Hi, this is Mrs. Williams, and we are going to talk about some different properties you'll use when you're doing proofs in geometry. The directions say name the property that justifies each statement. Number 15 says if the measure of angle A equals 53 degrees and the measure of angle T equals 53 degrees, then the measure of angle A must equal the measure of angle T. Well, that makes sense, right? But why? Well, what you are probably thinking in your head, if you're thinking that does make sense, is you're saying, okay, well, if they're both equal to 53, if angle A and angle T are equal to 53, then I could take angle T and I could put it in there. And if I do that, I'm going to get angle A equals angle T. And we could put measure of angle A equals measure of angle T. And that's where, the statement, the conclusion that was made there. And what you're doing when you are putting angle T in for 53 degrees is called substitution, or substituting it in. And so that's the property. It's the substitution property. This can also be considered the transitive property. We'll get to a little bit more of the difference between substitution property and transitive property in the next, in some of these examples here. But if you were thinking transitive property, you've gone over that property, that would also work there. But most people would probably think substitution, but transitive would work. Okay, problem 16. It says if 7x plus 2y equals 28 and y equals 2x, then 7x plus 2 times 2x equals 28. So this one's a little trickier. If you look at the conclusion and then you look at the first statement, the first part of this statement, they are very similar but a little different, and the difference is right there and right there. So the 7x plus 2 is the same. 7x plus 2 there, 28 on the right side of the equal sign. 7x plus 2 equals 28. But what they did, instead of y, is put in 2x. And the reason that you can do that is because this is true. And so what's really going on again here is substitution. If I know that y and 2x are the same from this second part of the statement, then wherever I see a y, I can replace it with a 2x or substitute it in. So this would be another example of substitution. Okay. Problem 17. If CD equals MN and MN equals RT, then CD has to equal RT. Now on this one, again, let's kind of analyze what's going on. You'll kind of want to look at your conclusion and you want to ask yourself, what happened? What changed? Okay, so let's look back. We have CD is equal to MN in the first statement. Then we have MN is equal to RT. Then CD and RT are put together. They're equal to each other. So if you look at each of the first couple of statements, you have MN, segment MN, that's in each of those equal equations there. And because CD is equal to MN and MN is also equal to RT, it would make sense if CD and RT are both equal to segment MN, then they have to be equal to each other. That's what the last statement is saying. Okay, now this is actually called transitive property. If you were thinking substitution, you're on the right track, and sometimes it's very easy to get substitution and transitive mixed up. The main difference between substitution and transitive property is in the order. If you've gone over the law of syllogism, this is kind of like that. You have CD, MN, then MN repeats, and then RT is different. So the let's grab a highlighter here. With transitive property, when you have the first statement and the sorry, I'm trying to switch back to my to my pen there. you'll have something is equal to something, like the first is equal to the second. Let's do numbers. And then you'll have the same thing repeating, second is equal to the third. And then the first and the third things must be equal to each other. So that's kind of the order. The MN there repeats. It's at the end of the first statement and the beginning of the second statement. So it's very similar to substitution. Same idea, but the order is kind of where the transitive property comes in. Okay, problem 18. We have segment EF is congruent to segment PQ, then PQ has to be congruent to segment EF. This property is called the symmetric property, and it's simply just flip-flopping. So EF got changed over here to the right side of the equation, and PQ got switched over here to the left side of the equation. All you did was flip-flop sides. They're still, of course, going to be equal, but when you just simply switch sides of the equal sign, or here the congruent symbol works the same way, that's symmetric property. Symmetric property. Those are two M's right there. Doesn't look like M's, but S-Y-M-M-E-T-R-I-C. Okay, 19. Okay, if angle G is congruent to angle H, and angle H is congruent to angle K, then angle G must be congruent to angle K. Alright, so let's take a look. We'll call angle G number 1, angle H number 2, and then if angle H is number 2, we have 2 appearing again, and then angle K. So we know that angle H appears at the end of the first equation, at the beginning of the second equation, and we're putting the first and the last thing together. We're saying, okay, well, if they are both equal to angle H, angle G and angle K are both equal to angle H, they have to be equal to each other. So again, because of that order, that's transitive. Okay, number 20. If 3x plus 4 equals 70, then 3x equals 66. Okay, this one's a little trickier. It's not quite like the other ones we've talked about so far, but it's actually easier in a sense because you've done this way back in algebra. Just ask yourself, how would I get from 3x plus 4 equals 70 to the equation 3x equals 66? Well, all you did, if you were back in algebra and you said, okay, I'm going to solve this for x, you'd subtract 4. Well, my subtraction sign doesn't want to stick there. But I would subtract 4 from each side of that equation. This 4 and this 4 would cancel, and then 70 minus 4 gives me the 66 over here. So all you write, the reason that I did that is because of the subtraction property. So just write subtraction property. 21. If KL, segment KL, the measure of segment KL, equals the measure of segment RT, then the measure of segment RT equals the measure of segment KL. Again, same statement. The only difference is that they have, switched sides, gone from left to right or right to left. That's symmetric. Symmetric property. Problem 22. If 2x plus y equals 33.5 and y equals 3x, then 2x plus 3x equals 33.5. Okay, do you see what happens? Let's look at this first equation, last equation, only slight difference there, right? We're looking at the y and the 3x. Originally we had y. Last statement we got changed to 3x. How did that happen? Well, this told us y and 3x are the same thing. So I can substitute 3x in place of y. So this would be substitution. Okay. So those are some one-liners. Oh, okay, a couple more. 23. If AC minus BC equals 12, then AC equals 12 plus BC. So look at what has happened in the second equation. Just mathematically, what has happened? Well, if you look here, AC is by itself. So let's look at the beginning equation and say, okay, how would I get AC by itself? Well, one way I would do that is to get rid of BC. So to do that, I would have to add BC to each side of the equation so that minus BC and plus BC cancel. And if I do that, I would get AC on the left side of the equal sign, and then I would have 12 plus BC on the right side, and that's actually what I want. That's what I have here in this statement. And how did I get there? That's what you're writing down, is how did I get from the first part of the statement to the second part of the statement. In this case, it's just by addition. So we just write by the addition property. Okay, 24. We have angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. Then angle 1 must be congruent to angle 3. So again, look at the order. We have angle 2 at the end of the first equation, the beginning of the second, and we say, okay, if angle 1 is equal to angle 2 and angle 3 is equal to angle 2, then angle 1 and angle 3 have to be the same as well. That's transitive property, again, because of that order that the statements are presented. All right, so those are some one-liners. Now we're going to actually put those properties into a proof. So problem 29 says complete each two-column proof. Okay, now these are, they definitely tend to be difficult at first, but what you want to do is just treat them, just pretend like they're those one-liners that we just did. Each statement and reason is really like a one-liner. Your statements, you're going to connect two statements together. So you're going to think of statement A connecting to statement B, typically. Now some of them do get harder because sometimes you'll have to connect 2 or 3 statements together. That's usually when it starts to get hard and confusing. But let's first read it, and then I'll try to break it down for you, make it make a little more sense. So our given information is information that we know is true. Okay, so let's read our given information. Given that the length of segment BC equals the length of segment CD. How we indicate that is by a tick mark. We'd put one tick mark on BC and one tick mark on CD, and that shows that those two segments are the same length or the same measure. We also know that segment AB is equal to segment DE. Those two lengths are the same. However, I don't want to just put one tick mark because that would indicate that segment AB and segment BC and segment CD are all the same. I don't know that. It doesn't indicate that. All I know that AB and DE are the same. So what you can do is add a second tick mark. So if I put 2 tick marks on AB, 2 tick marks on DE, that shows that just AB and DE are equal, just BC and CD are equal. Okay? Now what do I want to show? I want to show the prove statement. Okay? So given is where you're starting, prove is where you want to end up. We want to be able to know that AC is equal to CE. We want to be able to prove that that's true. So let's look at our segment. AC is from here to here, and we want to prove that is the same as CE, which is from here to here. And that would make sense, right? Just looking at the picture. But we want to mathematically prove that that's true. So that's a little bit different than just looking at it and saying, yeah, that looks like it should be true. Okay, so the first thing you should always get right. So if you get really confused, you think, oh my goodness, I have no idea how to complete proofs. I hate them. I do know that, you probably will feel that way. If you haven't yet, you probably will at some proof. But you should never, ever, ever miss the whole thing. You can always get the first statement and the first reason correct. Okay, if you look at the first statement, this is just the information that was here. And so the reason that you know it is because it was given to you. So right here, all we write is given. So let me grab my marker. Here we go, given. Okay, that information was given to me, so that's the reason that I put it in that first statement. Okay, now let's take a look at statement B. Okay, what's going on in statement B? Let's look. It says that segment BC plus segment AB equals segment CD plus segment AB. Okay, now this is really important to notice what's going on. Let's look back at statement A. Look at the very first equation, BC equals CD. If we look at statement B, we have BC and CD in that statement as well. The difference is that there's now an AB on each side. Okay? So we added AB to each side. So this is addition property, okay, because we are adding something to each side. And we also would put in there that it's the addition property of equality. If you forget the equality part, it's probably not a huge deal. I mean, check with the teacher that you have for the course and check. But if you have in there addition property, that's that you definitely need addition property in there. Let's put it that way. The part of equality, it just means that whatever you add to one side, you can add to the other, which the addition property does indicate. But it's better to put the whole thing. So if you can remember addition property of equality, that's the best. Okay, now let's look at the difference between statement B and statement C. They're very similar, except right here, DE. So statement B and statement C, you have the same equation, BC, AB, CD, they're all the same. The difference is DE. Well, you ask yourself, how would I get from statement B to statement C? What happened? What changed? How was I able to do that? Or how would I be able to do that? Well, we know, and this is where it gets hard, because we're actually going to take some information from statement A, put it with statement B to arrive at statement C. If we look at statement A, we know that AB equals DE. So instead of AB, we can put DE in its place. So notice this statement C is the same thing, except instead of AB, at the end we replaced it with DE because right here we know that they are equal to each other. So if you kind of think about those one-liners we did up at the top, that's because of substitution. We were able to substitute DE in for AB. Okay? All right, now let's take a look at from statement C to statement D. It says BC plus AB equals AC. Okay, now here's where it gets tricky. This statement D actually doesn't flow from C, B, or A. It's actually from the picture. So let's go back up to the picture and read that equation one more time. It's saying that BC, so this segment right here, plus AB, which is this segment, equals segment AC, all the way from point A to point C. The reason that that is true is just because of what's called the segment addition postulate. The segment addition postulate says, if you look at a longer segment, so if we look at segment AC, and you add up the smaller pieces, that they're going to be equal. So if I take AB and BC, which are part of AC, they have to equal AC. Okay, so it just is another way kind of to say, you know, the smaller pieces equal the whole. That's what the segment addition postulate says. It just is specific to segments. So that's our reason here. And same thing if we look at this one, that's what's going on here too. So if we look up at the picture, segment CD plus segment DE, what do those make up if you put them together? All the way from C to E. Okay, so that's segment addition postulate. Okay? Okay, now we're at our final statement. The one thing that I want to caution you on, a tendency of students is to want to write, okay, I wrote given for statement A. Here was the given information. See the word given, and here's my given information. So I wrote given over here. So, okay, this is my prove statement. I'm going to write prove over here. No, only works for given. So just keep that in mind. You're never going to write prove as a reason. Prove is what you're trying to prove, but it's not the reason that you were able to prove it. So what we want to do is we want to figure out how did we arrive here? How are we able to arrive here? Okay. So if you look carefully, let me grab a different color here. If we look at statement C and statement D, we're going to need to look at both of these. Look at BC plus AB. That occurs in both of those statements. Okay? And then, let me grab a different color. We'll just make this all color-coded here. We have CD plus DE and CD plus DE. Okay? Well, what is CD plus DE equal to? CE. So what I could do in statement C is I can replace that entire right side, the entire CD plus DE, with CE. I can also look at BC plus AB and see what it's equal to. It's equal to AC. So up here in statement C, BC plus AB is also equal to AC. So I can replace BC plus AB with AC. So if I do that, this is what the equation would look like. I would have AC on the left side. Actually, let me go back to blue. Okay, so I would have AC just from replacing the left side of the equation with AC equals, and then I'm going to replace this with CE. Oh, my equal sign doesn't want to stick there. Equals. Okay? And look, that's what I'm trying to prove. Well, how did I do that? How was I able to put AC into the left side of the equation? It was by substitution. I knew that BC plus AB was the same thing as AC, so I substituted AC into that equation. And then same thing with CE. I knew CE was equal to CD plus DE, so instead of CD plus DE, I substituted CE in on the right side, and voila, that's what I came up with. And so the reason is, okay, how did I get there? How was I able to get AC equals CE? It was by substitution. Okay, let's try another. All right, problem 31. Similar idea where we have a proof here. First, let's look at our given information. It says that the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180 degrees. And we'll find out, if you don't know this already, that's because they're inside of a triangle. So if you look right here, we have a triangle ABC, and the three angles inside of a triangle always add up to 180 degrees. Okay. Now you don't have to write that here for your reason. Remember, what you always write is your first reason. Well, this was given with, to you to start with. This was the true statement. It said, okay, here's a statement that we know is true. So the reason it was given to you is, or the reason that you know it's true is because it was given to you. So you just write given. Remember, that's the easy one. You can always get that one right. Oh, my writing here is, let me try that again. My G is a little out of control. Okay. This tablet is hard to get used to. Okay, given. There we go. Okay, statement B. Oh, let's look at the proof. What are we trying to prove? We're trying to prove that the measure of angle 1, right here, is equal to the same thing as adding angle 3 and angle 4. So whatever angle 3 and angle 4 are, if you add those together, it should equal angle 1. So if angle 3 is 20 degrees and angle 4 is 30 degrees, and you add those up, you get 50 degrees. Well, that's what angle 1 would be, 50 degrees. That's what we're trying to prove is true. Okay? Okay, so let's take a look at statement B. Statement B says the measure of angle 1 plus the measure of angle 2 equals 180 degrees. This one doesn't come from statement A. This is by looking at the picture. So if we look at angle 1 and angle 2, they form a line down here. Okay, so if you have two angles, these are called adjacent. They share this side. They share side AB. And if you look at the, the bottom sides, they make a straight line, and so they are called a linear pair postulate. And so that's the reason you write there is we know that a linear pair postulate adds up to 180 degrees. Okay, so let's take a look at statement C. How do we arrive at statement C? Well, we're actually going to take a look at statement A and statement B at the same time. If you look at statement A, we know that angle 1 plus angle 2 plus angle 4 is equal to 180. In statement B, angle 1 plus angle 2 is equal to 180. So if you know that they're equal to the same thing, what could I do, for instance, with that? If I know it's equal to 180, I could put it in that spot right there for 180. And if I do that, here's where it ends up. I have the measure of angle 1 plus the measure of angle 2 on the left. And then I was able to substitute in the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 on the right-hand side. So that's how you got to statement C, is by substitution. And again, this is so similar to transitive property, and if you put transitive property here, that would work as well. So I'll just put substitution or transitive property. They're very, very similar. Oops, I need an I. Okay, so let's take a look at statement D. This is where we're going to stop this proof because this is what I wanted to prove. This statement matches the statement that I wanted to prove. So you know you're done when you've arrived at the proof statement, okay? Because that's what you're trying, that's your goal. So once you're there, you can stop. The tricky part is getting there. So we actually want to look at statement C. And what I want to show you is what would happen if I subtract the measure of angle 2. Whatever I do to one side, and I'm looking at statement C, subtracting the measure of angle 2 on the left. If I do that on the left side, I also have to do it on the right side, right? And what would happen on the left is that the measure of angle 2, since there's a plus and a minus, positive and negative, those cancel out, become 0. And look at what happens. Same thing happens on the right side. What I have left is the measure of angle 1 on the left side, which matches what I have in statement D. And then on the right side, I have the measure of angle 3 plus the measure of angle 4. And look at that. That's what I have in statement D. So how did I get from statement C to statement D? That is what I put over here. Okay, so how did I get from statement C to statement D? What did I do? I subtracted angle 2 from each side. So my reason is because of subtraction, the subtraction property. And again, just like the last proof, the best, most technical thing to put here is subtraction property of equality. Probably if you just put subtraction, you'll be okay. But the most correct thing there would be subtraction property of equality. Okay, last proof for this section. All right, we are given that angle 1 is equal to angle 2, and how you indicate that is by putting an arc. So we can show angle 1 is congruent to angle 2. And it's always a good idea to just go ahead and mark up your picture. Eventually, what you'll probably do is you'll probably have to fill in some of the statements. Oh, see, even here, look, they didn't put that one in there. So you're going to have to fill that in. So sometimes they start getting a little harder as you go along. And the truth with proofs is that practice makes perfect. I know you might be watching the last two proofs and thinking, yeah, that makes sense, but I would never get that on my own. Well, you probably won't at first. You'll probably make a few mistakes. That's okay. That's how you learn. Just keep practicing. That's going to be the key, is practice, practice, practice. After you practice enough, and enough varies from person to person, but after you practice enough, you will get it. But it does take a lot of practice. These are hard, and each one's different. So, there's no formula I can give you to say, here's the magic thing that will work for proofs. You just have to practice, practice, practice. Okay, so we know angle 1 is congruent to angle 2. And we know that angle B plus the measure of angle 3 plus the measure of angle 2 equals 180. Okay? And we know that the measure of angle B plus the measure of angle 1 plus the measure of angle 4 equals 180. Okay, we can't really put that on our picture, but that's two good things to know. Okay, so let's look at statement A. Now they really threw you a curveball here because, oddly enough, and this rarely happens, but this reason actually isn't going to be given. Like I said, usually that's all, your dead giveaway. Occasionally, it will be out of order, like on problem 33. But let's take a look actually, and I'm going to do statement A, and then I'll show you there will be some reasons that will be given. But let's take care of this first statement first. You simply have something equal to itself. If you have something equal to itself, 50 equals 50, segment AB equals segment AB, here measure of angle B equals measure of angle B. Anything equal to itself, that's called the reflexive property. It kind of sounds like reflection. Like if you look in the mirror, you see yourself in the mirror, so you're kind of standing on both sides of the mirror in a sense, right? So reflection kind of sounds like reflexive, so that's what this property is, reflexive property. Okay. Now if we take a look at statement B, look at these two statements right here. That's actually your given information. Okay, so given's actually going to go in for statement B here. Okay. Okay, now let's look at statement C. I think you can probably get this. I know you can. If we look at, let's color code. So we have measure of angle B plus measure of angle 3 plus measure of angle 2 in statement B, and here it is in statement C. And then if we go up here and we look at measure of angle B plus measure of angle 1 plus measure of angle 4, we have that same thing right here. So look at what they're both equal to. They're both equal to 180. So what they did was they substituted. They took this pink statement and they put it in, plugged it in on the right-hand side for 180. And again, you could put substitution or transitive. Technically that would probably be closest to substitution. So if your teacher says, no, I want you to get this right, they're going to lean towards substitution on that particular case, just because the order, remember with transitive, really with transitive, what would happen is that, well, if I get my mouse to move here, you'd have 180 at the end of the first equation, and then 180 would be here. So basically in the second equation, these would be flip-flopped. That would be, for sure transitive. But here it can be interchangeable depending on what your teacher wants. So just check with them. Okay, let's take a look at from statement C to statement D. How would we get to statement D? Okay, well, if you look at the difference, the only difference between statement C and statement D is that we're missing angle B on the left side and the right side. So how would you get rid of angle B? Well, you could subtract it, right? So this is similar to that last proof that we did. If you subtract angle B, my subtraction sign doesn't want to stick there. Subtract angle B. There we go. It's going to cancel out on the left and the right, and that's how you end up with what's left there in statement D. So how did I get from statement C to statement D? Well, that was by subtraction. So I would write subtraction property of equality. Okay? Okay, now this one we haven't come across one like this where we have to fill in the statement. But it's not too hard of a one. They're starting us out fairly easy. The reason is given. So let's look at our given information. Which given information have we used, and which do we still need in this proof? Well, we've already used this second and third equation, so this has to be the one that they want. That has to be, that's the only thing that's left. So that has to go in for statement E. Measure of angle 1 equals the measure of angle 2. Okay? Okay, now where would they use that? Well, let's look at statement D and statement E, and statement F, actually. Let's look at all of them. Let me grab my highlighter again. Look at the difference between statement D and statement F. They're very similar, except right here in statement D, we have the measure of angle 2, and in statement F, we have the measure of angle 1. Well, how can you take angle 2 and put angle 1 in there instead? Well, it's because of statement E. In statement E, we knew that angle 1 is the same thing as angle 2. So instead of angle 2, you could put angle 1 in that spot, and that's what happened. So what's that called? Substitution. And that one's definitely a substitution one. The one, where you can interchange substitution and transitive is where you have like one whole side of the equal sign is being taken out and replaced with something else. In this case, just a part, just the angle 2 part is being replaced. So that, this is definitely substitution, just this piece. So if this whole entire left side or this whole entire right side was being replaced with something, then, substitution and transitive are a little bit interchangeable. But in this case, this is definitely substitution. The only thing that changed was just angle 2 got changed to angle 1 because I knew they were the same thing from statement E. So substitution. Okay, now let's look at from F to G. Okay, what happened from statement F to statement G? Well, same thing except I'm missing angle 1, and I have angle 1 on each side. So if I subtract the measure of angle 1, look what happens. Boom, boom, they're gone. So how did I get from statement F to statement G? I subtracted. So I write subtraction property of equality. So I hope that helps get you started off with proofs on a good foot. Good luck.